All right, class, welcome back for part two of um, the exam two review. We're going to start with number 4, and what we see here is I no longer write what it's on the review what we're looking for here, but I think we can see that it's just the region between the curves 2x and x squared. Um, Here's the graph, and I worked out where exactly they meet. They meet at x equals 0 and x equals 2. Maybe no big shock there. Um, Part B just says now rotate this about the x-axis. Well, we have a horizontal axis, everything in terms of x, so I think this is disk washer. So that means we need an area function. I think the outer radius is just the graph of 2x, and the inner radius is just the graph of x squared. And then we just integrate that from 0 to 2. Okay, rotating about the y-axis, I think this is just shell method, right? So we integrate from 0 to 2, 2 pi, and now our radius, well, that is going to be, since the axis is behind the region, if you take a peek up above, axis behind the region for shell method, it's variable minus axis, and the y-axis is just the line x equals 0. So this is just going to be x minus 0, which I'm just going to call x, right? And then upper minus lower, which is 2x minus x squared. And often if you just have x here, you don't even need the parentheses. Okay, number 5. Well, here is the graph of 1 plus y squared. It's the sideways parabola. And the graph of y plus 3 is this line. X equals y plus 3, I should say. They meet at y equals 2 and y equals minus 1. I'm having some deja vu, so maybe this was on a homework or something like that. If we're going to rotate this about the y-axis, then what you'll need, this is a vertical axis, everything in terms of y, so you need disk washer method. So first we need an a of y function. And the outer radius is going to be, well, formed by the graph of y plus 3, x equals y plus 3. And the inner radius is going to be formed by the graph of 1 plus y squared. And you'll notice that I don't need to modify at all. Even though I have sort of this gap here, it may look like it. Remember, it all depends on what your axis is. So my axis is behind the region. I'm using disk washer, so it's always function minus axis for each radius. Well, the axis is just x equals 0, so I'm subtracting technically 0, right, in both cases here. But that's just the same as just putting the function in both. And then, yeah, we just integrate this from minus 1 to 2. And then integrate with respect to y. Okay, rotating about y equals negative 2. Well, that's down here, right? So we're going to spin about negative 2. So what we're going to observe is that we're going to need shell method. And the reason we need shell method is because, well, if you look back up at the chart, you have everything in terms of y and a horizontal axis. So that is shell method indeed. And going back up, the axis is below the region, so it's going to be y, which is our variable, minus our axis, which is negative 2. So I think our single radius that we're going to get for shell method is y plus 2, which I'll write it like this, and then upper minus lower, which is y plus 3 minus 1 plus y squared. So like I said, I'm going to write this like y minus negative 2, but in reality you should write this as y plus 2, right? And it just comes from the fact that the axis is below the region. So you just, in shell method, you just take the variable, which is y in this case, and subtract it. I think we saw something like that on a recent homework. So please review that. All right, so moving down here to number 6. Well, here is the graph of x equals 9 minus y squared. And what we want to do is, I think in the setup it says chop it off at the y-axis. So everything between this curve and the y-axis. So you notice we get this whole big region here that starts at -3 and ends at +3. You'll notice I didn't solve anything because, I mean, think about it. If y is 3, then 9 minus y squared is 0. So it's going to meet here and also at -3 since you're squaring the y value. But if you really wanted to verify this, you would just set 0 equal to 9 minus y squared and solve. This is just a difference of squares, so factor 3 plus y, 3 minus y. And there you go. Okay, where was I? Oh, right, okay, so we want to rotate this about x equals -1. So that's this line, like back here, right? Well, everything is in terms of y, and it's a vertical axis, so disk washer, right? So we need a of y. Well, that's going to be pi outer radius squared minus inner radius squared. Okay. Well, let's see what we get here. So what forms the outer radius? So starting here, well, the graph, of course, the graph of 9 minus y squared forms the outer radius. But the axis is behind the region, so we subtract the axis. Well, the axis is -1, so you subtract -1, right? And so in reality, you would put a +1 here, right? Now the same deal. What's forming the inner radius? Well, it's the line x equals 0, but this axis is behind the region, so you subtract the axis. And so what we're going to do is integrate now to get the volume from -3 to 3. And now I'm going to write this like as we maybe should, with a +1, right? And here I would first, before expanding this out, call this 10 minus y squared all squared, and then go from there. Since you have a 9 plus a 1. Okay, and now rotating about the line y equals 4. Well, that's up here, right? So now I think the method we're going to need is different. We have a horizontal axis with everything in terms of y. So I think we're going to need shell method. So it's going to be 2 pi. There's going to be a radius, and now upper minus lower. Well, the upper is just formed by the graph of 9 minus y squared, because it's farther to the right, remember? And now the lower part is just 0. That's what's forming the left part of the region here. That's the line x equals 0, right, the vertical line. But let's talk about what the radius is, okay? The axis is y equals 4, which is above the region. So for shell method, if the axis is above the region, it's always 4 minus the variable. So I think it'll be 4 minus y in this case. And then finally, we come here to number 7. So what we're going to get is we have the graph of 3 minus x squared, which is this upside down parabola here, and x squared plus 1, which is this upward facing parabola here. And this is the region that we're going to spin about different axes. They meet at x equals -1 and x equals 1, no big shock. The outputs are 2 in both cases. So let's rotate about y equals -1. Well, that's down here, right? That's an axis way down here. This is a horizontal axis. Everything is in terms of x, so we're going to use disk washer. So pi times bracket outer radius squared minus inner radius squared. Well, what's forming the outer radius? Well, it's this 3 minus x squared graph. That's the one that's farthest away. But the axis is below the region, so technically we subtract it. So we get minus -1, right? So in reality, +1. And same deal here. We're going to get, for the inner radius, it's x squared plus 1, and then minus the -1, because the axis is below the region. So x squared plus 1 minus negative 1. And so to integrate, or to find the volume, we integrate, and I'll just simplify. This is 3 minus x squared plus 1 squared, and then x squared plus 1 squared. And of course, you should write this as 4 minus x squared all squared, and this is x squared plus 2 all squared, and then go about simplifying. Don't forget to integrate dx, right? Okay, and then finally, x equals 5 is a line way over here. I think you can see that we're going to use shell method, right? We have everything in terms of x with a vertical axis. So it's going to be 2 pi radius upper minus lower. Well, the upper is clear. That's 3 minus x squared plus 1 dx. And so the single radius that you get from shell method, I'll leave it to you to look above. But what you get is the axis is in front of the region. So for shell method, what that means is it's axis minus variable, so 5 minus x. Okay, there isn't really much to say about the remaining 2 problems. I think we got numbers 8 and 9 still to go. Number 8, I think you should at least be able to identify which method is being used, whether or not it's shell or disk washer. And then from there, just see if you can kind of piece it together, like come up with a picture of it or something. And then number 9 is just to kind of jog your memory with some basic integrals. So a and b are like e to the kx integrals. The antiderivative is 1 over k e to the kx, right? C and d, those are half angle trig identities. That's the only way you can do integral of cosine squared and the integral of sine squared. And then the last 2, they look similar, but remember, I think part E is the arctan antiderivative, right? Whereas part F, you'd have to use a u sub. So like put u equal to the bottom, and then du is exactly the top. So just review those. Make sure you can do stuff like that. I'm going to post an answer, the answer key early in the week. So make sure you're on the lookout for that. I'll essentially just re-upload the review, but I'll say that it's with the answers. And then one final thing that I want to remark is that the exam, I mean, look, if you can do all of these, and and even if you want to challenge yourself by changing the axis, so let's say you put the axis back here instead, or something like that, or put the axis, down here or up here, whatever, or in front of the region, challenge yourself like that. At least just get the setup. I encourage you to work it all the way out, of course, but if you can just like do the setup, and then you're at least in good shape in that way. But what I'll say is that I like to, on the exam, typically throw in an improper integral problem. So like, what if you had a region that was like that like went off like from 1 to infinity or something like that, and then use disk washer or shell method. I mean, the setup would be normal. It's just that one of your limits of integration would be like infinity, right? And you'd have to evaluate using an improper integral. So make sure you also review improper integrals. All right. Well, I hope to see you on Tuesday during virtual office hours with any questions that you're having. Otherwise, log on to virtual office hours, everyone, on Thursday morning at 9 a.m. Eastern. That's where we're going to have our check-in, and we will start the exam shortly thereafter.